Okay, so we're practicing the distance formula now. So find the distance between P1 and P2 when P1 is negative 5, 5, and P2 is 1, 6. So the distance formula is, write it up here again, x2 subtract x1 squared plus the change in y squared. Okay, so x2 subtract x1. So the square root of 1 subtract negative 5 squared plus 6 subtract 5 squared. So we'd add here. So I'd have the square root of 6 squared plus 1 squared. So that'd be 36 plus 1. So the square root of 37. And that doesn't reduce. Then we have down here, I did not give myself enough room to do this problem, let me tell you. I'm going to grab another piece of paper real quick. Maybe I'm not. Okay, so on this problem, I want you to plot these points first and then go from there. But when you're on My Math Lab, it's just match it up, So what we have to do to verify that this is a right triangle is we're going to need the distance between A and B. So we're going to need the distance between B and C. And then we're going to need the distance between A and C. So we're going to use that information to determine if it actually is a right triangle using the Pythagorean theorem, a squared plus b squared equals c squared. And then we're going to take that information once we figure it out and figure out the area of that triangle. So let's just start on this. So I'm doing the distance formula again, I just didn't write it again. So 3 subtract negative 4, because that's my 2x values here, which is going to be plus, and I'm squaring this, and 0 subtract 3 squared. So I'd have the square root of 7 squared plus negative 3 squared, and it's okay that it's negative because a negative times negative is. So here I'd have 49 plus 9, so this one is going to be 58. Okay, BC, starting over, I have 5 subtract 3 squared plus 1 subtract 0 squared. So I'd have 2 squared plus 1 squared. What did I do? Well, I messed up. I'm going to fix it real quick. So I did 5 subtract 3 when I was in my mad dash just then. It needs to be 1 subtract 3 and 5 subtract 0. So this is 1, which it's still going to be negative 2, so that's nice there. But this one's going to change because 5 subtract 0. I hope y'all don't care that I'm not starting a new video on this. So double check. 1 subtract 3 is negative 2, and 5 subtract 0 is 5. Okay, so negative 2 squared would be 4 plus 5 squared is 25, so this one would be the square root of 29. Okay, AC. I won't mess up this time. I say it, and I probably will. 1 subtract negative 4 squared plus 5 subtract 3 squared. So 1 subtract negative 4, which was 1 plus 4, because you can't subtract negative. 5 squared plus 5 subtract 3 is 2 squared, so I'd have 25 plus 4. Darn it. This is going to be an isosceles one, which isn't the best example. So now then, when I go to prove this is a right triangle, we are going to take the two shorter sides, so the square root of 29s. So the square root of 29 squared plus the square root of 29 squared equals the square root of 58 squared. And if it is a right triangle, this will be true. If not, it won't. And this is the Pythagorean theorem too. That's how we're proving it right now. So the square root of a square or the square of a square root, either way, they're inverse operations, so these are just going to cancel each other out. So I'm going to have 29 plus 29 equals 58, and 29 plus 29 is 58, so this is true. So when they ask you for the sum of the squares of the legs of the triangle, it'd be 58, and then when they ask for the square of the hypotenuse, it would also be 58. So legs, hypotenuse, which they're both going to be the same if it's a right triangle, and all the problems I assigned are right triangles, so keep that in mind. Now then, the area of a triangle is 1/2 base times height. Your hypotenuse will not be involved when you're doing area, so it's going to be the two shorter sides, and ours just so happen to be the same. So we'd have the square root of 29 times the square root of 29 divided by 2, or times 1/2, whichever one you want to do. Ours are going to cancel out because it'd be the square root of 29 squared. So we'd have 29 over 2, which is going to leave us with 14.5, and that's kind of scrunched because we just divided 29 by 2. There's some that obviously aren't going to have the same legs, and just remember when you get to them, multiply the square roots, and they like to use 400 a lot. So there was one that was the square root of 8 times the square root of 5, and that gave us so someone ended up with a leg length that was square root of 8, and then the other one was the square root of 20, I believe. 8 times 20, 160. No, that's not right. What was it? Well, I know there was a 5 too. But either way, when you start doing these, this would give us the square root of 100. So the square root of 100 would be the 10. Somebody had the square root of 400, which is 20. So you're going to have different ones of these that's going to come up. So when you have legs that aren't the same, multiply them and then take the square root of it. And then remember that for area, we're dividing these by 2. So that one would have been 5, and this one would have been 10. I hope that wasn't confusing. Email me if it was and you watched it this far.